Hey guys, here we go. Unit 14, lesson 10. This is going to be arc length. If you could answer your do now question first. What is the circumference of the circle shown below in terms of pi? So in case you forgot, circumference is pi times diameter. Now, if you forgot actually what circumference is in itself, circumference is just like perimeter, right? If you had a square where every side was 3, perimeter would mean add all the sides, right? Now, because a circle, we can't calculate the sides because a circle is round. You're going to use pi times the diameter. So circumference equals pi times the diameter. If we look at our circle, this 3.5, that's our radius because it goes from the center to the outside of the circle. If we were to extend that radius, then that would give us a diameter. So just simply we know to multiply that by 2. So our diameter should be 7. Circumference equals pi times 7. And now if it says in terms of pi, we're not going to multiply pi in our answer. We're just going to leave it as 7 pi and then with units, centimeters. So circumference goes all the way around a circle. But what if you just want to know the length, say, from here to here? We know that that portion of a circle is called an arc, and the length of it is going to be called arc length. So the arc length is the length of a portion of the circumference, and it's represented by the letter S. Arc length is going to equal whatever central angle it intercepts over 360 times the circumference of that circle, okay? And remember, circumference is pi times the diameter, okay? So if you want to know this arc, say in this picture, you're going to need this central angle and you're going to need the diameter. Those are the two pieces that you have to sub in to get arc length. Okay, so let's look at number 1. Find the length of arc AB in terms of pi, okay? So I'm going to use, instead of an X to represent my unknown, I'm going to use S because that represents our arc length. This arc length, okay, is going to be equal to our central angle over 360, which you think about it, that's an angle out of the 360 degrees of the circle, times their circumference, which is pi times your diameter. So the only two pieces we substitute into is that central angle and our diameter. Our central angle is going to be this 100 degrees. So from this circle, theta is 100 degrees. Our diameter, we can't get immediately, but we can get simply knowing that this radius is 3. That tells us that our diameter is 6. If we substitute that in, we have 100 degrees for our central angle over 360 times pi times our diameter. Okay, so now from here, we're leaving this in terms of pi. So what that means is you're going to have some number here in front of pi. And to get that number, what you're going to do is you're going to type in 100 over the 360. And the number that's left, and everything here is in terms of multiplication, is that 6. Okay? Now, in terms of the calculator X, I believe it's the same that you can just hit math, enter, enter after that to get it in terms of a fraction, okay? And I know on that app as well, that's how you're gonna have to type it in. If you wanna do it all in one shot, it would be 100 over 360 times 6. So you're literally just taking all the numbers and leaving pi out of it. And then that fraction is going to go in front of pi. So our final answer is 5/3 pi. And that's how we leave it. That's arc length. Number 2, the diagram below shows circle O with radii OA and OB. The measure of angle AOB is 120 degrees, and the length of the radius is 6 inches. What is the length of arc AB in terms of pi? So in order to get arc length, S, arc length equals our central angle over 360 times the circumference of the circle, which is pi times the diameter. The two pieces we need to get arc length is our central angle. Our central angle in this picture is 120 degrees. Our diameter we're going to get from our radius. If our radius is 6, our diameter is 12. Substitute. Arc length equals 120 over 360 times pi times our diameter. Now, again, it's in terms of pi. So what we're going to type in the calculator is everything but pi, and everything is going to be multiplied. So we have this fraction, 120 over 360 times 12, and that's going to give us 4. So our final answer is 4 pi. Number 3, a ball is rolling in a circular path that has a radius of 10 inches as shown in the accompanying diagram. What distance has the ball rolled when the subtended arc is 60 degrees? So be careful here, okay, before I finish reading. This is not arc length. This is the degree measure of the arc. So one of them measures how much of a degree of a circle it is. The other measures the actual length. Okay, so this is degree. If you were to take that curved piece and it was a string and you straightened it, it would not equal 60. Express your answer to the nearest hundredth. So this one's a little bit different also. It doesn't say in terms of pi. Okay, so anytime you are working with arc length, right? Because it wants distance. Distance is length. I need to know how long this is. And again, if it was a piece of string and I straightened it, how long would it be? That's represented by S, arc length. Arc length equals our central angle over 360 times circumference. Now our central angle, we know, is going to be this corner piece of the pi. I don't have it directly, but if I know that this arc is 60 degrees, what do you know then if this is a central angle? And you should be saying that it's also equal to 60 degrees, right? Because central angles equal the arcs that they intersect. The other piece we need is diameter. If the radius is 10, our diameter is 20. Substituting that in, we're going to have 60 over 360 times pi times our diameter. And now this one is nearest hundredth. So you are going to type everything in. So that angle of 60 over 360 times pi times our diameter. Type it in exactly like you see it. To the nearest hundredth, that arc length is 10.47. And the units mentioned in the problem is inches. Number 4. A sprinkler head is equidistant from flower garden A and a small shrub B. The sprinkler waters in a circular pattern. If the length of minor arc AB, so remember, AB technically can have 2 arcs. You can connect A and B this way, or you can connect A to B this way. The smaller one is our minor arc. So if the length of that arc is 12 feet. That is arc length. That is S. Okay, the last one wasn't because it was degrees. This one is a length. Okay? And the radius of the circle is 10. So radius is from the center to the outside of the circle. Find the measure of the central angle subtended by minor arc, AB, to the nearest degree. So although you're not solving for arc length, because arc length is involved, you still have to use that formula. Now it's a matter of what you're substituting in. Normally we would look at our central angle, but we don't know what that is in this case. That being said, because that's the piece we're solving for, now these are the two pieces we have to substitute in. Our arc length, which they gave us as 12. Our diameter we can get from our radius. If our radius is 10, our diameter is 20. Substitute 12 into arc length. Theta is what we're solving for. Pi times the diameter of 20. Okay, now what I'm gonna do just to make it look a little bit more clear, this is the piece that we're solving for, right? Well, that piece I know is over 360. And what that means is because division is involved here, you're gonna have to use multiplication to get rid of it, right? To make it cross out. I'm gonna do that first. Multiply both sides by 360, okay? So because everything is separated by multiplication here, and this is getting divided by that 360, that's gonna be our first step. 12 times 360 is 4,320. What's gonna be left over here is theta times 20 pi. To get rid of that and get theta by itself, the only thing in the way of it is that 20 pi. And because it's being multiplied, we're going to use division to make that 20 pi cross out. (4,320) divided by 20 pi, and this is getting rounded to the nearest degree. This 7 is going to round that 68 to 69 degrees. And that's going to be the measure of that central angle. Okay guys, so you're going to do the rest of the packet, which is consisting of 6 questions and a closure, all involving that formula, okay? So for the first couple, we were solving for arc length. Pay attention to if it says in terms of pi, if you're rounding, and then again, if you're solving for another piece, you just have to use what you're given. So because there's 3 substitution opportunities, one of them will be blank, 2 of them will be substituted into. Okay, if you guys have any questions, you know the deal. You can always message me. Have a great day.